Hello, and welcome to the Thinks of Code channel. I'm thrilled to have you here as we embark on a coding journey together. In today's session, we'll delve into the fascinating world of connecting multiple databases, specifically PostgreSQL and MongoDB, using the power of Node.js. So, buckle up and let's dive into the world of versatile database connections with Thinks of Code. Initialize your Node.js project. Create a new directory for your project and open a terminal. Navigate into the directory and run the following command to create a package.json file. npm init-y. Install dependencies. Install the necessary dependencies, including Express and any other libraries you may need. For a simple chatbot, you might want to use a library like PG and Mongoose for Create Database Connection Pool. Install these packages using npm install express pg mongoose. Welcome to today's tutorial on connecting multiple databases in a project using Visual Studio Code. In this tutorial, we'll explore how to set up connections to different databases, such as PostgreSQL and MongoDB, in your Node.js project. Let's dive in. Welcome to Connect Multiple Database, a Node.js project designed to demonstrate the seamless integration of multiple databases within a single application. Let's delve into the project structure to understand how it works. Our project is organized into an app directory, where the core functionalities are housed. Within models, you'll find the heart of our database operations, the database model.js file. The database model.js file is a versatile model capable of interacting with different databases. It acts as a bridge between our application and the database systems. In the controllers directory, we have the datacontroller.js file. The datacontroller.js file orchestrates the flow of data within the application. Here, we dynamically choose the database connection based on specific criteria, ensuring flexibility in working with different databases. The routes directory contains the dataroutes.js file. The dataroutes.js file defines the routes for our application. It connects the incoming requests to the corresponding controller methods, facilitating a smooth flow of data through the system. Now, let's explore the config directory, where we manage the configurations for each database. The postgresconfig.js file holds the configuration details for our PostgreSQL database. Similarly, the mongoconfig.js file contains the configuration settings for our MongoDB database. Finally, the index.js file serves as the entry point to our application. Here, we bring everything together, defining routes, connecting to databases, and starting the server. And there you have it, Connect Multiple Database, a project that seamlessly integrates multiple databases in a Node.js environment. This structured approach allows for flexibility and scalability, making it easier to adapt to changing requirements. Let's take a closer look at the database model.js file, the backbone of our Connect Multiple Database project. The file begins with the declaration of the database model class. In the constructor, we initialize the class with a database connection parameter, representing the connection object to the specific database. We store this connection object in the dbopt property for easy reference within the class. Next, we have the getData method, responsible for fetching data from the connected database. We start by checking the type of the database, specified in the dbopt.type. If the type is Postgres, we execute PostgreSQL specific logic. Here, we use the query method of the PostgreSQL connection to fetch all rows from the data table. If the type is Mongoose, we execute Mongoose specific logic. We first ensure that the Mongoose connection is valid. Assuming the data model is defined in the Mongoose connection, we use it to find all documents in the data collection. The lean method is applied to obtain plain JavaScript objects instead of Mongoose documents. If the type is neither Postgres nor Mongoose, we throw an error indicating an unsupported database type. Finally, the class is exported for use in other parts of the application. And that concludes our line-by-line exploration of the database model.js file in Connect Multiple Database. This versatile model allows us to interact seamlessly with different databases, making our application adaptable and robust. Let's dive into the PostgresConfig.js file, a key component in configuring our PostgreSQL database connection for the Connect Multiple Database project. The file begins by importing the pool class from the PG module, which is a popular PostgreSQL client for Node.js. The pool class provides a pool of connections, enhancing the efficiency of database operations. Moving on, we encounter the configuration object, PostgresConfig. This object contains the essential parameters needed to establish a connection with the PostgreSQL database. The user property specifies the username for authentication. The host property indicates the location of the database, in this case, localhost. The database property holds the name of the specific database we want to connect to. The password property stores the password for authentication. The port property signifies the port number where PostgreSQL is running, defaulting to 5432. Now, let's look at the instantiation of the pool using the provided configuration. The pool variable is created as a new instance of the pool class, with our configuration object passed as an argument. This pool is essentially a collection of connections that can be reused, enhancing the efficiency and performance of our database operations. Lastly, we export the pool object, making it available for use in other parts of our application. And there you have it, the PostgresConfig.js file. A concise script that configures a connection pool for PostgreSQL, providing the foundation for robust database interactions in our Connect Multiple Database project. Welcome to the exploration of MongoConfig.js, a vital script in our Connect Multiple Database project, dedicated to configuring the MongoDB database connection. Let's begin with the import statement, bringing in the Mongoose library, a popular tool for working with MongoDB in Node.js. Now, let's focus on the MongoConfig object. Currently empty, this object will soon house various configuration options to tailor our MongoDB connection. Next, we initiate the connection to our MongoDB database using the mongoose.connect method. The method takes two arguments, the MongoDB connection string and our configuration object. In the connection string, we specify the protocol as MongoDB or MongoDB plus SRV, the server location is your connection string path, and the name of the MongoDB database we want to connect to your Mongo database. As we wrap up, the final line of code exports the configured Mongoose object, making it available for use throughout our Connect Multiple Database project. This export allows other parts of our application to leverage the configured Mongoose instance, streamlining database interactions. There you have it, the MongoConfig.js file, setting the stage for a seamless MongoDB connection in our Node.js application. Today, we unravel the logic within the datacontroller.js file, an essential component of our Connect Multiple Database project. We start by importing the database model class from our custom model file, and the necessary components from the Mongoose library for MongoDB. The database model class is a versatile model capable of working with different databases, providing a common interface for data retrieval. Next, we define a schema for our data using the Mongoose library. The data schema captures the structure of our data, including fields like first name, last name, email, mobile, and the database type. Each field in the schema corresponds to a specific attribute in our data. With the schema in place, we create a model named data using the mongoose.model method. This model will be used to interact with our MongoDB database. Now, let's explore the getDynamicData function, the core of our data retrieval process. We start by dynamically choosing the database connection based on a request parameter. If the parameter indicates Postgres, we use the PostgreSQL connection, otherwise, we use the MongoDB connection. The chosen connection is encapsulated in an object, indicating the database type and the corresponding connection details. With the database connection determined, we create a new instance of the database model using the chosen connection. Using the common model, we fetch the data from the selected database. This is the power of having a unified model that adapts to different database systems. Finally, we respond to the client with the retrieved data in JSON format. In case of any errors during the process, we log the error and respond with a 500 internal server error. Concluding the file, we export the getDynamicData function, making it accessible for use in other parts of our Connect Multiple Database project. And there you have it, the datacontroller.js file, orchestrating dynamic database connections and data retrieval with elegance in our Node.js application. Welcome to the exploration of the dataroots.js file, a fundamental part of our Connect Multiple Database project, responsible for defining routes and directing incoming requests to the appropriate controller. The file begins by importing the Express module, a powerful web application framework for Node.js. This module simplifies the creation of web servers and the handling of HTTP requests. Next, we import the data controller module, which contains the logic for our dynamic data retrieval. The data controller module, as we've seen earlier, dynamically fetches data from either a PostgreSQL or MongoDB database. Moving on, we create an instance of an Express router using Express Router. The router is then configured to respond to a GET request at the /dynamicdata endpoint. The GET request at /dynamicdata is directed to the getDynamicData function within the data controller module. Concluding the script, we export the configured router, making it accessible for use in other parts of our Connect Multiple Database project. And there you have it, the dataroots.js file, defining a route that triggers the dynamic data retrieval process orchestrated by our data controller. Let's explore the index.js file, an integral part of our Connect Multiple Database project that brings everything together, defines the server, and sets the stage for data retrieval. The file begins by importing the Express module, a crucial component for building our web server. Express simplifies the process of handling HTTP requests and responses in Node.js applications. Next, we import the dataroots module, which contains the route definitions for our dynamic data retrieval. These routes direct incoming requests to the corresponding controller methods. Moving on, we create an instance of the Express application using const app equals express. We define a constant port and set it to 3000. This will be the port on which our server will listen for incoming requests. The app_use/data dataroots line tells our Express app to use the routes defined in the dataroots module. The /data prefix is added to the routes. Finally, we instruct our app to listen on the specified port. The callback function logs a message to the console, indicating that the server is running and accessible at a specific URL. And there you have it, the index.js file, orchestrating our server, utilizing the defined routes, and preparing to respond to incoming requests. Hello, I will exploring the PostgreSQL data structure using pgadmin4. Examine table properties, and explore the data within the selected table. Let's dive in. Ensure you have pgadmin4 installed and running. Log into the pgadmin dashboard and navigate to the Servers section on the left-hand side. Once connected, navigate to the database you're interested in exploring by expanding the Databases section. To understand the structure of your table, right-click on the selected table and choose Properties. Let's take a closer look at the structure of our sample table. It appears to have columns such as ID of type integer, first underscore name, last underscore name, email, mobile, all of type text, and DB underscore type of type text. Understanding this structure is essential for effective database management. Here, you'll find information about the table, including the number of columns, primary key constraints, and more. Take note of the table structure. To select a table, expand the Schema section under your chosen database. Navigate to Tables and right-click on the table you want to examine. In the context menu, select View Data, View All Rows. To view the data within the table, right-click on the table and choose View Data, View All Rows. This will open a new tab displaying the contents of the table. You can browse, filter, and analyze the data conveniently. Firstly, make sure you have MongoDB Compass installed and running. Open Compass and connect to your MongoDB server by providing the necessary connection details. After connecting, you'll see a list of available databases. Select the database you want to explore. Today, we're going to focus on a specific database, so let's expand that database. With the database expanded, you'll see a list of collections. Collections in MongoDB are analogous to tables in relational databases. Right-click on the collection you want to explore and choose View Documents. In the View Documents tab, you can see the documents within the selected collection. MongoDB documents are JSON-like, so they consist of key-value pairs. Here, we have a document with fields such as first underscore name, last underscore name, email, mobile, and DB underscore type. The underscore ID field represents the unique identifier for the document, and object ID is an automatically generated identifier by MongoDB. Feel free to browse through the documents, filter data, and explore the collection using MongoDB Compass. You can also edit documents, add new ones, or delete existing ones, making it a powerful tool for managing MongoDB data. Hello everyone, and welcome to today's tutorial on running a Node.js application, utilizing Postman to make GET requests with dynamic database connections. We'll explore two endpoints, one fetching data from a PostgreSQL database and the other from a MongoDB database. Let's get started. Ensure your Node.js application is up and running. Open your terminal and navigate to your project directory. Run the command node index.js or the appropriate command you use to start your Node.js application. Now, let's open Postman to make requests to our dynamic endpoints. If you don't have Postman installed, you can download it from the Postman website. Once installed, launch the application. Our first endpoint is /data/dynamic data with a query parameter db equals postgres. This indicates a dynamic connection to a PostgreSQL database. In Postman, set up a new GET request with the URL http://localhost your underscore port /data/dynamic data db equals postgres and hit send. Upon successful execution, you should receive a response containing data fetched from the PostgreSQL database. This dynamic connection allows us to switch between databases seamlessly. Now, let's explore the MongoDB endpoint. Use the URL http://localhost your underscore port /data/dynamic data db equals mongoose in Postman for a dynamic connection to a MongoDB database. Hit send to execute the request. Similar to the PostgreSQL request, upon success, you'll receive a response containing data fetched from the MongoDB database. The flexibility to dynamically connect to different databases enhances the versatility of our application. Thanks for watching. Don't forget to like, subscribe, and leave your comments below. Until next time, happy coding!